so much clouds.
I think we're live.
No, last night was pristine.
We're going to interrupt and continue this conversation in a moment because we're now streaming on YouTube.
Okay.
And we're live on this 11th of September, 9/11. Wow.
9/11.
For episode number 134 of our beloved SBAU Astro Hour. I'm Ron Heron, Vice President of the club. Proud to be. I'm going to introduce you to some of the other board members and movers and shakers in a minute. It's a weekly Monday morning, 11 to noon podcast or blogcast, if you will, for SBAU, Santa Barbara Astronomical Unit, South Coast, Central Coast, the longtime Astrophysics Telescope Club, all centered at and supported by our beautiful and amazing Santa Barbara Museum of Natural History. Learn all about us on our club's website, run by the esteemed Tom Totten, our webmaster, sbau.org. Better yet, come on down, show up for when we have them. Star Party was canceled due to God's plans for the night in the sky Saturday. Friday general meetings are on the first Friday of the month, and we had a grand one last time, and we're going to be talked to all the way from the New England era by a columnist for Astronomy Magazine named Bob Berman. You'll get all that, Tom, in here in a minute. Let's introduce the president, though, first of all. Hello, Mr. President.
Good morning.
Good to see you. That's Jerry Wilson. His wife is Pat Forgy. Brings her along. She's a supporter, longtime member. Tom Whittemore used to teach science. There he is at Westmont College. Pretty much runs things as far as our, what is it, third Friday of the month when we go out to the Westmont?
I don't really run things anymore. I think, Ken has kind of taken over the reflector upstairs and the refractor. So I like to spend a lot of time with Tim and, the folks who walk through the area to look at stuff, so I like to stay downstairs,
Okay. And the Tim you're talking about is to the right of you.
It's right there. There's Tim.
So a bunch of ugly old men talking heads with mustaches. And Tim Crawford, who's married to Karen, and is a staunch supporter and member, and pretty much runs the workshop on Tuesday nights. That's another blog podcast, right? Tomorrow?
Well, yes. We have, but I don't really run that anymore. Jerry and Tom Totten really have taken that on, and Jerry does a spectacular job. There's a lot of astrophotography sessions going on now with that, as well as mirror making. So it's really good. But if anybody ever has a question to ask of the group, they get first at bat. They really do.
Well, I sat in on one probably years ago, and man, I didn't say anything, but I was overwhelmed. And Jerry and you guys do a good job. And
you ought to hear it now, Ron, with all the astrophotography. There's so many acronyms and names for all these things that it's
right. When I say, Ron, when we used to have it at the Broder live, Tim and Jerry and I were pretty much always there. You came to at least one of those. It was really nice.
And it was even more fascinating.
Pre-COVID, right? Pre-COVID.
That's a little building they shut down across the creek in the back there, right? That's called the Broder Building?
Well, no, they still hold like wedding receptions and things like that. And it's also set up for science for little kids.
Yeah,
making things, building things. Yeah, it's a classroom, like Jerry said.
Yeah. It's also one of the more dangerous places because I understand there's dinosaurs running around in that area.
You got to watch your step.
That's right. Tom is married to Bonnie. No, he's not. He's married to Maureen. And Tim is married to Karen. And Jerry is married to Pat Forgy. And our esteemed outreach coordinator is still in deepest, darkest Ireland, isn't he?
Ireland.
Chuck and Pat McPartland.
They're getting ready to come home, though. They're antsy to get back.
Oh, I would imagine. I sent them off with some thoughts I'll see if they come back and bring me something. However, let me run by these headlines for you. It's the time of the comet. We'll talk about the incoming Nishimura, which is going to be probably headlining everything, starting things off. Winter constellations are arriving. We'll talk about this hour. There are two crescents out there. One is the moon. The other is the next planet in toward the sun. Going to take a look at a couple nebulae. I believe that's how you do plural, right? AE at the end, including one with a big bubble, another with a dying sun inside. They're all pretty much similar, but Saturn has a picture taken from Earth, and we have a picture of Earth taken from Saturn, we're going to see. Plus, Here it is, the big one. What does that Sirius Web picture of all those distant, really distant galaxies, it's kind of rattling things up in the world of astronomy, have to do with a scene in Jurassic Park that scared the P1 out of us? We'll talk about that. We'll start with Nishimura, but if you could put together, Jerry, during this, somehow go from one nebula to the other nebula. I think there's something in between. I like to keep my topic similar. And the moon is in there too, of course. It's about to go away by the end of the week, right?
Yeah.
Yes.
Great talking points, great pictures. Why is it called Nishimura? It's named after him.
He's the discoverer.
And it wasn't that long ago, was it? Was it August?
No, late August.
August, yeah.
And he was an amateur like us.
Yeah.
Any one of us could find a blob in the sky and have it named after us, couldn't we?
If you spend the time out there to look for it, yes.
And why couldn't the big pros find it? Well, you got to stumble upon it. Nothing alerts. They don't have an AI that says, "Ha! Look in the lower left part of the sky."
No, they have several. Sometimes they just miss it.
Sometimes they miss it. All right. Well, for September 11th through the 17th, this is number 134, and kicking it off is our temporary webmaster, longtime beloved, up for re-election again, as I am in about 3 months. Jerry, what's going on? You got pictures for us? Perihelion, right?
What's that?
Perihelion for the comet. That means it's going to whip in around us and go within, I guess, Mercury's orbit, right? Oh, the sillies. I totally forgot about our forwarded silly science cartoons. Look at this. Turn it on its side and it's a duck. Or as the Marx Brothers used to say, viaduct. Why not a porpoise? Why not a goose? Now, this one you're going to have to explain to me. I'm sorry. I've totally forgot about the cartoons. Went right to the regular stuff. Now, explain this to us. The guy hanging is
The guy hanging is obviously annoyed by all the math he has to take. And he'd like to do just physics without the math, but he doesn't really get the connections.
Yeah.
Now, when I was in school, in high school, in 1960 to 62, we took physics in the senior year because it required more math. And the math in high school started out with algebra in junior high, then went to geometry, trigonometry, and then math analysis, which was introductory calculus. And you took that at the same time you took physics, because physics required the most math. Nowadays, I find out from my children that they've changed that. Physics is the first science you take because it doesn't require any math. It's a conceptual thing. So I think that's a pretty crummy way to teach physics.
Yeah.
But apparently kids are afraid of math. And that needs to be addressed, not avoided, in my view. So this reminded me of that.
I was told that the easiest math course to take would be under psychology, and it's called statistics. And it's the worst thing I've ever had in my life. You solve things with like 11 steps of formulas and equations before you get to the answer, and you have to know all 10 or 11. You remember any of that? You're taking skewed bell curves and things like that?
Yeah, they used to teach it.
Yeah.
Did you really? Oh,
Yeah.
Yeah.
Well,
It is probably the simplest form of math. The only thing simpler than that is economics. Of the 4 functions in arithmetic, economics only uses 2 of them.
Is that right? Well, quadratic equations did me in algebra B. Cows in Greece speak ancient Greek, and that is the moo word, right?
Mu.
Mu.
Yeah.
Yeah.
Well, same thing, but whatever. Somebody looking through this telescope has seen something headed our way, it looks like, and he turns gently to his co-partner and says, "Please run, get out of here," like it's going to help. You know, the big giant. My friend got a degree in Egyptology, but can't get a job. So he's paying more money to get a PhD so he can work teaching other people Egyptology. Doggone it. In his case, college is literally a pyramid scheme. Okay, then there's the duck. And here we are. Okay, oh, you had others. Let's see, down under, upside down tanker. Another up.
Oh, yeah. No, I didn't. I thought that was pretty silly. I didn't show it.
You sent us a video that would not load on my
Yeah, I went back to it and it wouldn't load on mine anymore either. So I
you're
just,
kidding. Well, what was
Yeah.
it about? Straight line. If it's a video from YouTube, we should be able to just type it in.
I'll work on that for later.
All right. Here's the Nishimura. Now we're back to the main stuff.
Yeah.
I jumped the gun. Wow.
Yes,
That's
this
how it
is
looks.
the comet was discovered by a guy named Nishimura. It's officially called Comet C2023P1 Nishimura. It will reach, let's see, it's heading toward perihelion. It's about 90 million miles from the Earth right now.
Okay.
That's so in your head, you can put that around the sun in a circular orbit because we're about 90 million miles from the sun too. So we're both about equal distance. This picture was taken on September 7th.
Okay.
It
So
was
that's
taken
Thursday.
with a 16-inch telescope f3.2 from I don't see the name down here, but it's by Michael Yeager.
Is that how it would be configured in the sky? Would it be going up?
In this particular picture, it is probably moving toward the upper part of the screen, but in the sky, it seems to be moving downward.
Right.
Okay,
So pictures can get arranged any way.
that's true. You got to do
It
what
was
you do.
discovered on August 11th,
Okay. Over
and it will make its
exactly a month.
closest. Go ahead.
I just said it exactly a month ago.
Yeah.
And it will make its closest approach to Earth on the September 13.
Okay.
Is it green?
So that's Wednesday.
It is green,
Yes.
isn't it?
It's kind, yeah, this is a black and white picture. This is a color picture.
Wow.
There, that looks more like a comet to me.
Yeah, and this is heading down, you see. If you can rotate the picture any way you want.
Mm-hmm.
So
Yeah, so it's going through Leo right now, Ron.
Oh, is that where it is?
Yeah, and Leo comes up just before the sun comes up now.
When are you going to see it, Tom?
Well, I was hoping to see it this morning because I did see the moon come up, but I saw the bad clouds. Okay, and the moon and Venus were close to one another this morning, but I couldn't even see Venus. I just saw a little crescent moon, like a smile in
Okay, yeah, right. Going away.
in the northeastern sky. So
They're not close together, though. They're not in the same part of the sky.
this morning, tomorrow
I think
morning, they'll be 11 degrees apart.
Well, Jerry, are you and Tim Crawford, are both of you going to try to see it?
Depends
Yeah,
on
this-
the sky in the morning, yeah.
yeah, this is a binocular object, Ron.
Yeah.
So you,
Oh, is it?
Possibly even a naked eye object.
yeah.
This glow down here is from the sun.
Mm-hmm.
Mornings only.
Yes, it's heading toward, towards the sun, and the sun is going into Virgo right now. So yeah, it's heading towards Virgo.
What is that? The moon?
No,
No. That's your comment.
this is the comet, and the circle around it is blown up here, so you can
Oh.
see it better. But this is the relationship to the pre-dawn sky or the dawn sky.
Mhm.
So as the sky is brightening here in the part of it that's still dark, you can see it. And it looks like it's almost a visual
Yeah,
naked eye object.
because I think it went by the beehive, right, Jerry?
It did for a while ago.
Mhm.
Right now, it's right here. Today is 9/11.
Yeah.
The anniversary of 2001.
Yeah.
Now, what is the magnitude again, Jerry?
Let's see.
Is it like 5?
It's it's magnitude 5, but you got to remember with an extended object like this, that doesn't mean that you can see it. It means that if you gather the whole light of all the fuzziness and put it together, it's magnitude 5. So on September 6th, it was recorded as magnitude 5 by photometric measurements.
Mhm.
It's roughly magnitude 4 last Saturday, 2 days ago. It's expected to brighten through perihelion, to continue brightening through perihelion, perhaps to magnitude 3 or even 2 before it disappears from view.
Wow. Yeah. So Ron, magnitude 2 is like Polaris. And again, Jerry mentioned this is a collective magnitude.
Well, I heard or read somewhere it was going to rival Venus.
It's
Yeah.
going to be in the same sky with Venus. That means that's the rival, not in brightness.
But we won't be able to see a tail on it, will we, without a telescope, I guess, in the dark?
No, you might. The picture back here is very hopeful about being able to see a tail.
Right.
This is
And
not
you'll
a long exposure. You can see how
Mhm.
the stars are still points. They didn't track for a long time on here.
Yes, right. Yeah. And always in competition with the glow of the sun, Ron.
Yeah. So by the end of this week, it will be down below the horizon. It will be too close to the sun for us to see.
But then it'll repeat by going back out, won't it? Just a
Yeah,
mirror.
the other side, yeah. If it survives its close encounter for the sun, but it sounds like it's very far away, so it shouldn't be. It's not a sun grazing comet, so it should survive.
Okay,
Probably
well,
head down toward the southern hemisphere.
And doesn't the P indicate periodic, Jerry?
Yes.
Yeah, okay, so periodic, so it'll come back sometime.
they haven't figured that out yet?
No, they have the orbit for
If,
us.
if they say periodic, I'm sure they have.
Yeah.
Well, I mean, let's say it's on the scale of a Halley's. Halley's every 70 something years. What if this
Yeah.
one were every 30 or 40 or 80 years?
I don't recall the period. It could be very long. Could be,
Yeah, it could be
80,000
2,000
years.
years.
But it wasn't expected. I mean, we expect
No.
Halley's to come back, and there's others that come back, but we just got to plot their. As
Right.
far as science knows, comets never just jettison themselves with a parabolic out into space and never ever come back and become an Oumuamua.
No, they do.
They do. They do.
Yeah.
And some
Oumuamua did.
I know that's what that. Okay, Oumuamua was a cigar-shaped one that came through for the benefit of you folks that don't know it.
The
But
cigar shape seems to be pretty popular, but it could also be pancake shaped. They couldn't tell the
Yeah.
difference between the two.
all right, edgewise. But
Yeah.
otherwise, something kicked this out of the Oort or the Kuiper belt.
Or it's been traveling on this orbit a long time. It might be its first visit to us because it's got a lot of volatile elements on it.
Mhm.
Well, we never have anything go around that's the size of Pluto, do we?
Not yet.
That would be a strange planet, or dwarf planet anyway. Okay.
Pluto would make a very nice comet, because Pluto has an atmosphere when it's closest to the sun at its perihelion. And at its aphelion, its atmosphere is frozen on the surface. So it doesn't have an atmosphere. So if it gets really close to the sun, it would make a spectacular comet. All that nitrogen and carbon dioxide and carbon monoxide blowing off of it.
It also has a pretty big sized moon, doesn't it? Is in relation Charon or Charon?
Has 5 moons.
I'm still stuck in the old days, but it just had one. Mars has 2, but they're nothing but big rocks. And Charon is like a dwarf planet itself, I think, isn't it? Or moons are not classified as such, but
Close to it, yeah.
our moon is pretty good size, and it is a globe.
I think our moon is the biggest moon in percentage to its parent planet.
Is it really?
Yeah, there are moons that are bigger than our moon, but their planet is Gigando, Jupiter.
And Titan, for example, around Saturn is one, I think.
Yeah.
Okay, fascinating stuff. Well, I want to see some pictures if you guys have your cameras on board.
Okay.
There we go. Remember that scene in Jurassic Park when they're getting
This
away
is
from the T-Rex? And who's in the car there?
Jeff Goldblum.
Goldblum, that's right.
Yeah.
I think he's got a broken leg and he's going up. Could we go faster?
Yeah. Spielberg's a genius. This is awesome. This is great.
He's
And now
definitely a creative movie maker.
somehow you're going to connect this to those distant galaxies that Webb just
Yes.
about 5 or 6
I don't
of
have a
them.
lot of pictures of that. It's a lot of text. So let
Finally
me
getting around
check
to this.
that.
Okay.
Yeah, this is actually a picture, a fabrication, a simulation they call. I don't know how you would do a simulation of what James Webb would see if they did a ultra deep sky scan of its galaxies. But this shows a lot of distant galaxies. Now, the issue that that's been come up in the last year is that the James Webb Space Telescope has seen 6 galaxies that are at a distance from us that puts it in, as Neil deGrasse Tyson says, in the dark part of the dark region, the dark time frame when nothing was producing light, but yet we see them, so this is producing light. So it flies in the face of the Big Bang Theory. And also the galaxies, if they are not in the age of darkness, then they're too big, because we believe that it takes a long time for galaxies to get that big by accretion of stars and collision with other galaxies. But some of these are back at virtually the beginning, a few 100 million years after the beginning of time. And yet they're giganto, they're big, they're fully developed, they're mature. So this one group has gone back and looked at that, and they published a paper that recalculates the estimated distance. And there are 2 ways to calculate the distance to galaxies that early by
spectroscopy. Is that what it is?
Well, one of them, there's a photometric method, which is not that accurate, but is quick and dirty. And the original distances back to these galaxies were calculated using quick photometric stuff. So, but a much more accurate way of doing it is the spectroscopic method, which is longer, more complicated, but it's much more accurate. And the photometric method, which was used, depends on statistics around sort of a bell-shaped curve. But when you're looking at galaxies at the very beginning of the universe, it's not a bell-shaped curve, because you're up against the hard wall of the beginning of time. So it's more like a Lorentzian than a Gaussian curve. And so the statistical variation done with the photometric method really doesn't work. And it led to significant overestimation of the distance to the galaxy and the time that they are in. And when you use the more accurate spectroscopic measurements for these redshifts on the order of 9 to 14, you get much more reasonable values. You get let's see, I didn't highlight the key thing here, but it basically resolved their point of view. Their analysis basically resolves the difference. We don't have to throw out the Big Bang Theory. Nothing contradicts it. It does not throw it out. They are much more recent galaxies than the first estimate was. They're not back that far in time.
Now, Jerry, our missing link on the screen, Chuck might be watching us where it's, I guess, 7 o'clock at night back in Ireland. And,
I don't think so, though, Ron.
You don't think he might be watching this? But my question was, I've tried to bring this subject up before, and you guys hadn't really decided. You were still gathering information. He pretty much agrees with you, doesn't he, on this? Well,
his point of view was that don't rush to judgment.
Okay.
In science, we have a phrase that says, don't jump to conclusions, because you frequently have to walk back in public view. So the idea is that you wait till all the data is in and the data has been analyzed and critics have picked it apart and adjusted it. That's how science works. It's a discussion, it's a process. And he just didn't want to jump to a conclusion, but he can say this himself when he's back next week. But he didn't want to jump to conclusions before all the data is in. And this is a significant reinterpretation of that data.
Well, can I ask a couple of questions based on what we all know? And it's just occurred to me that if the universe were not expanding, but collapsing, all these distant distant galaxies would be ultraviolet, right? They'd be bluish, not reddish, right? Coming toward us. Is Andromeda coming at us? Is it ultraviolet? Does its light waves shift up in the spectrogram rather than down because it's not going away from us? Do you follow what I'm saying?
Not yet. Go ahead. Try again.
The light waves of something going away from us are stretched and they go down into infrared,
Yeah.
which is everything out there except pretty much the local group. Are they all ultraviolet? Or is their light stretched toward the upper part of
No,
the?
they're not moving that. They're not moving that rapidly toward us because they're very local to us. They're only moving 100,000 miles an hour or something. Or
So that doesn't affect the light waves being stretched.
you could, with proper instrumentation, you can see the blue shift in their light.
Yeah, depending on whether you're on the right side of the swirling stars going away from us or on the other side where they're coming toward us.
Uh-huh.
That side of the galaxy gets red or a little redder, and the other side gets a little ultraviolet. Does that make sense? Do you know what I'm talking about?
Yeah, that's how we tell that they're rotating.
Okay, but why wouldn't these distant galaxies go down into the radio spectrum eventually?
We do. We go down, as a matter of fact, the original fireball, you might say, we look in the microwaves for. It's the microwave background. It's been redshifted down so far that it's in microwaves.
That's that modeled
Which is
green.
past radio waves.
Okay, that's that modeled green background thing with some green
Yeah,
and little
yeah.
specks.
The big football shape with the modeling.
Yeah, I think the prime wavelength, Jerry, is more like a centimeter. So I mean, it's really been stretched, right?
Yeah.
It's more like a centimeter.
Okay.
But now the Webb telescope is centered on infrared, and it saw these distant galaxies in infrared. What if there were galaxies that had really gone so far and were actually they go farther away from us than the speed of light, so the light waves never reach us, right? Some of them.
That is most of the universe is beyond us, and we'll never see it.
Right.
We
So
see back about 13.8 billion years, and the radius of the universe is somewhere around 45 billion years.
Mm-hmm.
Okay.
So we only see the first 13.8 billion years of the 45.
Okay, but the Webb has probably reached the limit then with those 5 or 6. And that was only in one direction.
Those apparently are the farthest away that we've identified as far away, but they're not as far away as we originally thought.
Oh,
They're just a tad closer.
Hey, Jerry, do you mind one question from me on this subject? I know that in light of this new information about the distances are now they're much closer than they thought. Is that going to do anything to the cosmological theory, whether we're a flat universe, round?
The cosmological constant.
Yeah, is it going to do anything to that, to change how we see the shape of the universe?
No, I don't think so.
Okay.
There's still a difference between the cosmological constant, the Hubble constant, and how it's measured, that has not been completely resolved. This is akin to that, but it doesn't help resolve it.
but these deep fields that we've seen pictures of, first from the Hubble and now from the Webb, that have shown one little dinky splinter of a piece of the sky, of which there's a jillion more pieces they didn't look at. Do you follow what I'm saying?
Yeah.
There may be quadrillions of those type of distant galaxies that are red, and maybe they're all closer than we think, maybe not. But how come we only got 5? That's only a tiny little piece of the sky. I guess we can't quite...
Like in this deep field picture, which is a simulation, there's a lot of galaxies here. Some of these galaxies, like the white ones and the blue ones, and these things are more foreground objects. The real small one down here are possibly much fainter, farther away. So you have to go through and scan some of these things and find the ones that are very, very far away.
Well, if they turned the Webb around and looked at the other half of the sky, they'd see the same thing, right? Only different galaxies.
The basic is, there are several assumptions that have not been, we have no evidence that they're not correct. And one is that the universe is the same everywhere. It's homogeneous. No one is favored over any other. And another one is that the universe is isotropic. It's the same in every direction.
Okay, that's hard for me to comprehend because to me, a Big Bang represented a place where it happened, where it started. How can
It
that place be
represents,
everywhere?
represents everywhere.
Is that right?
Yeah, you're thinking it was like a hand grenade going off. It was an explosion.
Exactly.
It was not an explosion.
Yeah, it's not fireworks on a, in a parking lot, Ron.
Yeah.
Jerry's got a new word for it, the big hand grenade.
What was it? We had a cartoon a few months ago from Calvin and Hobbes, where that they had a new word for the Big Bang. It was the gigantic, horrible kaboom or something like that. And it had a GHK as the symbol for it, something like that. And I guess that's been adopted by some astrophysicists when they talk about it.
Well, you guys have your hands full, I got to tell you, trying to explain to me where I get it, that one little pinpoint in space is everywhere now around us.
The one thing that I think I always marvel at is if you see these business pictures, like for example, the stock market, and you see all the structure in the time plot of the stock market, it's just this wiggly thing that goes up, and tens up or tens down or something. And then they predict the future. And from the point that is now, then they draw a straight line. It's never a straight line, because they really oversimplify things. And they did it with the Big Bang too, for conceptual things. The thing from Carl Sagan was that the universe, if you take a movie of the universe, it's getting bigger and bigger and bigger. And if you run the universe backwards, it's getting smaller and smaller and smaller. Well, you just extrapolate back from smaller to smaller and you come down to a point. And that's just the extrapolation, but there is no evidence that the universe came from a point.
Well, you've heard the comparison to a rising loaf of bread that's filled with raisins. And all the raisins are growing distant from all the other raisins. Every raisin.
That model, Ron, is dear to my heart.
Okay, if
bread baker.
If you were on one of the raisins in the middle, everything would be going away from you, obviously, in equal directions. But what if you were in a raisin that's on the surface or the outside or near the edge?
Same thing.
No, it wouldn't be the same thing. You'd look one direction and there's not many raisins because there's the edge of the loaf in your oven there. Whereas the other direction,
you're presuming an edge, Ron. I think that's dangerous.
Well, I got
there's no evidence there's an edge to the universe.
There you go.
Loaves of bread, whether they have raisins or not, have edges.
Well, if you keep on this argument, some people will be raising cane.
I have a comment here real quick, and I've been monitoring the chat, and Mary's watching right now. She had a question that kind of fits what we're talking about here. Is that your understanding is space is uniform, that it is more a logical principle. Actually, she said we can never see the velocity greater than the speed of light. And
in the universe,
you're talking about. Pardon me.
In the universe, yeah.
And I remember that this is interesting about the raisin loaf is that Alex Filipenko, the guy you're trying to get, Baron, he uses that as well as a balloon with stars on it to talk about the universe. And we asked him about these questions, and we were saying, well, where if this balloon is the universe, well, what's in the middle? And I think his answer was nothing.
You have to think of the balloon as being a two-dimensional universe.
Right.
We are on the surface of a four-dimensional balloon, and then we have three-dimensional raisins in it. So you have to ignore the edge because that's not in the universe. The edge is the universe is the two-dimensional surface of the bread being rising.
And the center...
One last comment here is that, again, with Alex Filipenko, he was talking about the universe from any standpoint you were talking about, Ron, looking out, that the universe is not only expanding, but accelerating. And when he was talking, this is what I told Mary. One of the things he said is that as it's accelerating, it can actually accelerate beyond the speed of light without breaking the rule of the speed of light.
Yes, the idea is that in the see, the universe is a medium. It's not nothing. And that medium is a elastic medium. It has a stress tensor associated with it. That's why we can see gravity waves, because when you make the universe compress, so the fluid that is the universe, it restores itself. And so you have a medium there that we know is there that supports gravity waves. And anything that moves through the universe cannot go faster than the speed of light because of the medium it's in. But the universe itself can expand faster than the speed of light. And when the universe expands faster than the speed of light, it carries the raisins with it. And from one raisin's point of view, some of those raisins appear to be moving faster than the speed of light, but they're not locally moving faster than the speed of light. They're in the part of the universe that's moving faster than the speed of light from us.
Yep.
And that'll give you an Excedrin headache to think about for a while.
I think that Mary, I hope we answered your question here. She's writing more stuff here, but I'm going to see how this works out with the chat this week.
Okay.
It's pretty tough going back and forth.
One of our new members, Mary Magrant. She's going to be one of our major contributors in the club. You watch.
Yep.
Thanks, Mary. Hang
Good.
in. All right, let's look at the night sky here with Jerry. What's ready for us here?
Okay.
Fucking
This is the morning sky.
aha.
This is the prelude to winter. We're getting to the winter constellations. The winter skies have more bright stars in it than summer does. So you're going to get Orion, which is not shown here. But the harbinger of winter is the M45, the Pleiades. It's a young open cluster, less than 100 million years old. Has about 500 stars in it. It's quite dramatic. It's tricky to take pictures of because usually your scope won't fit it all in.
It's huge.
Yeah, it's big. And I put it in here because the Baron is always commenting that to him it looks like a little dipper. And that's
Everybody
true.
sees that. A lot of people.
Everybody asks that at star parties.
Yeah, it's a common
winter.
question. So Astronomy Magazine refers to it as not a small dipper, but as a tiny spoon.
Okay.
So
Are we talking about the Pleiades?
yeah,
Yeah.
the Pleiades. It's an asterism. It has a shape to it that people readily spot, and it looks like a little teeny dipper, but it's not.
I count 5 stars, 4 for the cup and 1 for the handle.
Yeah, Ron, in a good sky, human eye can see at least 6.
Yeah.
Oh,
If you're pretty good, you can see 9. I think Steve O'Meara probably sees more than 9.
Okay, but that's an asterism, but it's also part of which constellation?
It's an open cluster, Ron.
Oh, really?
Mhm.
Isn't
And
it an
like Jerry-
asterism? It's an asterism.
Are young. Those are young
It's in
stars.
Taurus, the bull.
Right.
What's it? Oh, that's my sign. Okay.
Yeah, but look, see, the thing is, here's the telltale for me is this little
Mhm.
line
Right.
of stars that always hangs down a bit. But there's a short handle and there's a small dipper
Yeah, there
kind
they
of
are.
thing. But that is when you spot a pattern like that, that's an asterism. It just means that's how you recognize it. That's its spotting feature.
But that's not the
And this is a
asterism.
very
on it?
nice.
It's not the Little Dipper.
No,
It's
oh,
not.
no.
What's it
No, this
This
called?
is the tiny dipper.
Well, it's got another name. It's a whole different thing, doesn't it? Don't they call it
What is
something
that?
else?
Ladies.
Just the Pleiades.
Yeah, the Seven Sisters, the Pleiades, Subaru.
But what we're looking at is a star cluster, and those 5 or 6 stars just happen to be the closest to us or the biggest.
There's about 500 stars in this cluster, but
And
those,
Yeah, I was going to say, Jerry, they're about 400 light years away. And
yeah,
we all say at star parties, I'm sure you've said this too, that, the stars you're seeing tonight, started their light journey when Galileo was looking at them,
Wow.
he thought,
And it looked the same to him, probably, didn't it?
yeah. I like to, if conversation goes to it, I like to tell people at outreach that the sky is not in the position it appears to be in. It never was in the position it appears to be in, and it never will be as it appears at this moment, because all the stars are different distances away. They emitted their light at different times long ago when they were in different positions, and they've all moved since then by different amounts.
Right.
Oh, that's an interesting comment, Jerry.
Yeah.
It-
And the
really
other thing,
nice.
Ron, it is the, you know, these stars, you see all the blue around them. So
Yeah.
that reflection nebula, so that doesn't really belong to these stars. They're moving in concert through space, and they're just whacking into this cloud of dust and stuff. And so it looks like a beautiful blue reflector as they move.
Are there some star maps you can get a hold of that'll show you the tracking that computers have done, and they'll have arrows showing where
Yep.
they're headed and how
Yep.
fast, and they're all.
Matter of fact, you can get a planetarium software and you can do it yourself.
Oh, is that right?
Yeah.
Yeah.
Wow.
Speaking of planetariums, you guys, so Maureen and I, we took our guests yesterday to the planetarium show at, I think it's at 2:00 yesterday afternoon. And that was the first time I got a chance to see the new projection system. It's really spectacular. It's really nice. I recommend people go and see some of these shows. Ours was about the birth of the Earth, and it had stuff to do with about the moon, the birth of the moon with Theia, you know, coming in. That was really neat. It's really neat. So
Did the new programs director, John Wankowski, run the show?
No, it was, so we showed up at one that you could have it in Spanish if folks there were native Spanish speakers. And although a bunch of us, you know, Maureen and me and her brother speak Spanish, you know, know Spanish really well. If somebody comes in there who's not native Spanish, then they go back to the English. And so it was clearly a Hispanic kid who was going to run the show, but he went ahead with the English version. It was really good.
Well, one thing I learned Saturday at the board meeting online was it has 59 seats. And I think it had a couple more before they had to install those new projectors, right? But we got one new one in the middle where the old projector used to be.
Yeah.
Yeah. Well, when we first came here back in 2003, I used to teach for City College there. And there's these really stiff, round racks of seats going around an old fashioned, I think it was a Spitz projector that I learned on. And it was very uncomfortable. These seats are, you obviously you can fall asleep in them if you're not careful.
Yeah.
Was
that Alice, Tom? Was that the old Alice?
Yeah, is that what they called it, Tim?
They called it Alice.
Alice, yeah. So it turns out that was, you know, when I first came here and, you know, taught for City College at the little planetarium, it just reminded me of growing up in Indianapolis and going over to Butler University because it was the same darn machine. So it's the same machine. In Indianapolis, besides having more than 1 million folks now, has a 36-inch reflector way up top of these stairs. You got to climb up to go to. It's really interesting. It's called the Holcomb, HOLCOMB, Holcomb Observatory. If anybody want to look it up, you know, on the web at Butler University in Indianapolis.
Are there any universities or colleges out there that have planetariums, or are they just in museums of natural history?
Where I went to grad school, U of A has a wonderful planetarium.
Oh, right.
Besides having Kitt Peak not too far away.
First time I ever knew that. Okay, learned something. All right, where are we? Back to the
It's
same.
called, I forget the name of the one, but it's right on campus in Tucson, U of A.
Okay, so, but what does Neil deGrasse Tyson run? Hayden, that's
the Hayden in New York City.
Right.
Is it a museum of natural history?
I think it's now called the Rose Science Center, if I remember right.
Oh, that's it.
Yeah, and the one in Chicago's Adler. You know, most major cities have really cool planetariums. You know, like I know Jerry knows the one in LA real well. You know,
Yeah.
Well, I used to go to the Fleet Theater in Balboa Park, San Diego, but that's an IMAX. That's movies. And
I see.
And yet they could do an incredible program in there if they wanted, if they had the right. I guess it takes special projectors, right?
Yeah. So I know I don't want to start take away Jerry's star show here.
Tell us what this is, Jerry. What are we looking at?
Okay, we don't have to stick to the talking points. These are just a safety net in case we run out of things to talk about. So this shows the morning sky tomorrow morning, and the moon is down here. two crescents. Venus is a crescent.
Mhm.
The moon is a crescent. The moon is a thinner crescent than Venus is right now. Venus is waning. Is that right? Yeah, it's waning. The moon
Mhm.
is waxing. So no,
I think
the
moon's
moon is
waning.
waning. Venus is waxing.
Waning over the weekend.
In the moon, and
And-
I did see the moon come up in the clouds this morning. So because of the cant of the ecliptic, the moon looks like a little smile. Okay, it's like the fill in. The fill in is down. Okay, it's down. It's like a smile.
But the new comet wouldn't be anywhere in this picture.
Oh,
No, there's
yeah.
the asteroid Juno in here, but the new comet, it's in Leo, and I don't recognize. Let's see if they have anything. Canis Minor, Leo Minor. Leo's somewhere over here.
Yes, yeah.
So this is 5 o'clock. The comet is up a little later than this, more towards 5:30 or 6. But it won't show on this planetarium because I don't have the comet entered into the sky 6.
Okay. Mhm.
So anyway, this distance between Venus and the moon is 11 degrees.
Okay.
Tomorrow
Oh, okay.
And that's tomorrow. Yeah.
morning at the 12th at 5 a.m.
Of course, closer this morning, but
Yes.
Venus got blotted out in the clouds.
But we
Yep.
get a new moon one Friday,
Thursday, I think.
Thursday.
Yeah, there you go.
This is what it's like tomorrow morning at 5 a.m. This is the moon.
Does
So
anybody
you-
remember what is 10 degrees? Is it a closed fist? Is that 10 or is it the
What?
when you hold your fist out at arm's length? Is that 10
Oh,
degrees?
that's 8 degrees.
8 degrees.
Yeah.
Okay.
Huh. Wow. Well, the moon is half a degree, so put two of them
Mhm.
together, you got 1/360th of the circle around the Earth.
Yeah.
So it's one.
So the moon is the Venus is 22 moons away from the moon.
Okay.
I'll be damned. You suppose ancient man.
And this
Go ahead.
this is actually very accurate because you can also see the in the evening they call it the new moon or the old moon and the old moon and the new moon's
New
arms.
moons.
But this is the new moon and the old moon's arms because it's going away.
Well, just a historical point of view, because you and Chuck are always into history. You suppose the ancients thought that part of it went away, the black part we couldn't see? Could they understand that we're looking at a distant sun shining on what little that we can see the reflection off
It
of?
depends on your cultural beliefs and what people were taught back then. There's one thing that I remember from being a child, that one culture believed that there was a dragon. Some Asian culture, there was a dragon that progressively ate the moon away.
Yeah, that's right. Chinese. Chinese.
And they never put two and two together, and we get a separate crescent on the other side with the new moon after it.
Yeah.
Mhm.
But a lot of people figured out what was going on.
I'm sure they did. Wow.
This is Venus. This is September for 2023. Sunrise sky. The
Dotted line. What's the dotted line?
right here, September. This is after it passed conjunction with the sun. August 11th, September 1. Here we are at September 11. It's continually widening. In November, it'll be half phase, but it's a bigger crescent percentage wise than the moon is right now.
Why does it show in blue, Jerry, and not white?
Artist preference.
Yeah.
Oh, okay.
And I can't read it, but what's the dotted line or the?
This
section?
is the celestial equator.
Oh, okay.
That is. This dotted line, that's the dashed line. This dotted line is the path of Venus with respect to the celestial equator.
Around
And
the
the celestial equator is the Earth's equator projected onto the sky.
right. It'll go from the east to the west. Yes.
Huh, it goes up and down. It's
Mhm.
not
Goes all
exactly,
around.
it's not exactly on the same as the ecliptic of the sun, though, is it?
No,
No.
Does it go above and then below the ecliptic with?
Right.
at some point, yes.
Bubbling.
Interesting. And what is this?
Now,
The moon.
Thursday, we're going to have a new moon. And that's a perfect time to look for this, which is the zodiacal light.
Oh,
This is a cone of light scattered off of dust particles in the solar system. Because the moon, if you're in a dark side away from city lights, when the moon is not in the sky, there's a chance of seeing this in the morning this time of year.
some people mistake it. They call it a fake sunrise.
A false dawn, false sunrise.
And Rhonda, if you looked at the inclination of the zodiacal light, so that's the inclination of the ecliptic, the plane that contains Earth and the sun.
Right.
So you
All
see
the
how
planets are in there.
it's canted real steep.
The old Nishimura, the comet's going to add a little to that, isn't it? Leave some of its dust behind as it goes around.
Mhm.
Yes, it is. The when comets go around, they shed. That's the next slide.
Mhm.
This shows a schematic of our solar system with the asteroid belt as this band going here between Jupiter and Mars. And these white tags and red tags are comets or asteroids that give off crap. And so we've seen pictures before of asteroids giving off pebbles, which was mistaken by a spacecraft for stars until they realized that they were moving with respect to the comet or the asteroid. So asteroids give off pebbles and rocks, and comets give off fine-grained dust and sometimes rocks and pebbles. And the rocks and pebbles tend to stay in the orbit of the object they were with, fly in formation. And when we pass through one of those orbits, then we get a meteor shower, all the pebbles and the dust. But sometimes a lot of the dust just diffuses into the sky. It stays way out here, and that becomes the cloud that shows up as the sunlight scatters off of, and you can see it, all this dust that comes from these objects, mostly comets, because it's finer dust and chemicals, water and CO2. Baron?
Well, at one time, let's see, the Leonid, what's the other one? Those were
Perseus.
comets.
The Oranians, the
Yeah,
Pegasus.
meteor showers.
Yeah.
And those comets did pass through the Earth's orbit. We weren't in that part of the orbit, but they have to pass through it.
Yeah,
Mhm.
because they were in the ecliptic plane of the ecliptic too.
That's right.
Well, they were.
Yeah, and some of them that are not in the plane of the ecliptic, we pass right through them too.
Well, now the
So,
Kuiper belt,
they pass through.
the Kuiper belt is pretty flat like a donut. It's more or less within the ecliptic, but the Oort cloud is a shell, isn't it? It goes everywhere.
Yeah, yeah.
So if it comes from the Oort cloud, there's a good chance it's not going to be
In the
same
ecliptic.
disk plane as all these orbits. Fascinating.
Good, yeah.
So we may not get a Nishimura regular meteor shower every year if it doesn't hit our orbit somewhere, right?
But in the meantime, we could look for it in the morning sky.
I know that.
Yeah.
We won't get any of its meteors. It's little dust particles.
So some things we've seen around other stars with the James Webb and with other telescopes is we can see a dusty disk around those stars.
Wow.
So they may have spectacular zodiacal lights.
Mhm, mhm.
You know what's really amazing about all these things we learn on this show like this?
Yeah.
Every one of those stars that we watch is a stellar system, probably with similar phenomena. They got their own zodiacal light. They got their own ecliptic. I don't think the planets they're finding around distant stars are going like an atom in all kinds of directions. They're all in a plane, aren't they? Pretty much.
That's right, they are.
Mhm.
Conservation of angular momentum.
Because that's
all
how they
come
were
from the
formed.
Same body.
But they probably all have an Oort cloud of their own
Very likely.
and various moons and rocks.
Yeah, when they have a planetary disk, that disk came from a planetary globe at one point. And as in our case, not all of the globe has collapsed into a disk yet.
Well, everything's moving. Have they found anything that isn't moving? Isn't going somewhere or spinning?
The motion, motion is relative to
That's true. Yeah, you're
the
right.
observer.
The
So
expanded
if you're
universe.
flying in formation with something, it's not moving. If you're both moving, you're not moving. It's a tricky definition.
Well, we're supposed to get out of this little spur, this Orion spur, which is in between a couple of the big arms, and go into one of the arms in a few million years, right? Our solar system. Have
I
you heard
don't
that?
recall that.
Yeah, okay.
I
Well,
think we all pretty much move around there. The arms are basically a traffic jam passing backwards through the rotating disk.
you want to talk nebula, bubble, or dying star?
This is about dying stars, and the easiest one to see is because it's located in the constellation of Lyra, which is this very characteristic parallelogram up there next to Vega. This star is directly overhead in the early evening. I got a crick in my neck from staring at it with a laser.
Yeah, no kidding. No
And
kidding.
right
Dobson's old.
halfway between these two stars, Sulafat and Sheliak, is M57, the ring nebula. The Cygnus and the Milky Way are over here. There's a lot of stuff in there. Sometimes I just point my scope into the Milky Way and then try and figure out what it is I'm looking at. Because
That's a cool way to do things.
Yeah.
But just because it's a white dwarf, that makes it a dying star?
Yes, because at least this is the ring nebula M57 taken from a major telescope. This is a star that's like our sun. It was not a heavy star. It's when its nuclear fuel ran out, all stars are a balance between forces pushing out and gravity pulling in. And the force pushing out is the energy generated by nuclear fusion. When it runs out of fuel, the nuclear fusion stops, and then there's only gravity now unopposed. And so it collapses the star in. And when the star collapses, it's sudden, and it comes in so high, it slams, and then there's a reverberation, a shock wave that goes out, and it throws off the outer layers of the star. And that's what you see here with this big ring. And the star that threw it off was this star in here, which is a 15th magnitude star. You generally cannot see it in our telescopes, the 5-inch and 10-inch telescopes that we bring to outreach. Charles Schuler has been bringing his 20-inch to some of the events, and you could see it in there if the sky is clear enough.
What do they think the future of the white dwarf is going to be?
I
Neutron?
was just going to cover that. Thank you.
Okay.
So this, as they say, it's a dying star. Its nuclear fusion has stopped. It's not fusing anything anymore. It's just a ball of ash left over. Whatever elements were made from the fusion, iron and above, that's just there. It's made, and it's hot because in the compression, in the gravity pulling it in, it heated up from internal friction and from the collapse. So it got real hot. It's white, which means that its temperature could be as high as 60,000 degrees, much, much hotter than our sun. But it's not generating any new heat, just gravitational collapse heat. So that will eventually run out because it's not producing anything new anymore. So eventually it will fade, it will cool down, and it will just become a dark star. And there's probably a lot of them out there. They're not black holes. They're just stars that have turned off. They've aged out.
Really? They're not neutron stars. They are
No.
heavy though, aren't they?
They are heavy. They can be neutron stars. The gravity pulls them in against their own resistance. When you want to push atoms close together, they resist that. And you can feel that when you push your finger against the wall. The electromagnetic field in the atoms in your finger is pushing against the electromagnetic field in the atoms in the wall. And so when you try and squeeze atoms together, they resist that motion, but gravity can be stronger and it can pull in more. It can pull in the atoms have to give. And so you actually end up pushing the electrons in the atoms into the protons. Did I say that right? Yeah, and that produces neutrons. So the entire star can be crushed down by gravity so much that the only thing left is neutrons. A white dwarf is not necessarily going to go there. It just might go to a really crushed set of atoms.
Well, my understanding about neutrons is that they are a proton and an electron squished together. They become a neutral.
That's right. That's right. And the
And
force
that's
that does that, the force that pushes them together is gravity, the weight of all the other mass pushing on them.
Might it become one of these dreaded magnetars if somehow there's a lot of magnetism?
If it's spinning.
If it's spinning, that's what makes a
it's
magnetar?
Spinning, yeah, then it can become a magnetar. Magnetic fields are generated by charges in motion.
Oh, okay. And magnetars are usually the same thing, a dying star or a remnant of a supernova. That
It's
is what
something that has collapsed, which has sped it up quite a bit. High angular conservation of angular momentum again. And then it's got charges in it that flow and produce, because of the spin, and produce a magnetic field.
sometimes it's spitting out a spinning what is it? Like a fissure?
jet, yeah.
A jet one way and the other way, right? And you can tell.
Well, do we have time for a comment too, Mary? Is it possible?
Go ahead, we'll go over.
Mary was saying that she's thinking about getting some binoculars, because we were talking about that the Pleiades is a great binocular object. And I'm just wondering if Tom had any kind of suggestions for binoculars. You know, I know you don't want them too heavy unless you get a Canon binocular.
Got a steady.
I think you definitely want to get an image stabilized one.
The Canons make a good image stabilization. That's a good one, Mary. They're expensive, but really nice.
You mean it counters your own body shaking things?
Yes. It's got like a little built-in gyro.
Wow.
Something.
Well, that's been my problem with you got to hold it against something or put it in the crotch of a tree or something.
I hope that helps, Mary.
Let's look at our last two pictures.
Okay. Oh, this is awesome. Picture of Saturn taken from the Earth, ladies and gentlemen.
Yes, this was an amateur photograph. This was taken by Damian Peach.
Oh, he does good stuff.
He's an amateur, yeah.
Is he in our club?
No, he's in Australia or England or somewhere like that.
And this is the Cassini picture, right?
This is a picture taken from Saturn. This is Saturn and its rings taken by this Cassini spacecraft, which has since then crashed into Saturn. And this is us down here.
Yeah.
Taken from
hello there.
Yeah.
You suppose the Cassini is still somewhere in the cloud tops or covers of Saturn, or is it vaporized into nothing but atoms by now? Probably.
It's got squished. They're probably burned up on entry.
Yeah. Well, next week I guess we get Chuck back. Chuck and Pat, at least Chuck and Pat will be monitoring. And thank you, Mary, for joining us offline, and the rest of you. And tell your friends and Tim and Tom and President Jerry, I wish you well and take care of yourselves. I hope you don't have to wear your masks before long again. But
see you at Bacara.
Yeah. Okay. We'll talk to you there. See you next week for number 135, I believe we're going to be doing.
Chuck will be back.